this is Chaitanya. So my topic in the seminar is supporting confidential workloads with zero trust networks using SPIFFE and SPIRE. So this is the agenda of today's seminar. We'll just walk in through the introduction about zero trust, then literature review of the past works, and then research gap, industrial impact, implementation, SPIFFE, SPIRE, results, conclusion, and future work. So, what is zero trust? Zero trust is basically following the principle of never trusting anyone and always verifying before giving access to resources in the system, which means all the systems of users are verified and authenticated before granting access to any of the resources in the system. Zero trust architecture is a new security model that is gaining very much traction in today's enterprise world. And going through the literature review, implementing zero trust cloud networks with transport access and first packet authentication is the first paper which I have reviewed, and the model uses a token inside a TCP packet which identifies and validates a user. This method was used to prevent DDoS attack, and the second paper is towards a model for zero trust. And zero trust requires robust identity and access management system that can verify the identities of all the users and devices before granting access. So this paper discusses about the IAM of a system that it should have in order to implement zero trust. And coming up next is this augmenting zero trust architecture to endpoints using blockchain. Blockchain is a secure and distributed system. So with the help of this, we can build a tamper-proof audit trail of the endpoints. This can help in detecting threats more quickly and effectively. So this can be augmented with the current zero trust architecture. The next paper was access control policy enforcement for zero trust networking. The author of this paper proposed a framework policy, uh, and the framework policies included two framework languages for zero trust networks. One of the language for writing access control policy was Parole for general access policies, and FACL for firewall rules. This was a mechanism to map the specific firewall syntax into the rules in the firewall. So this framework is flexible enough to support a variety of different firewall platforms. So it is scalable and can be managed across managed access control for large complex environments. The next paper is establishing a zero trust strategy in cloud computing environment. The proposed model is involving stakeholders and dynamic environments where every users are not trusted, and you should inherently not make a user in trustworthy, and must verify all the users before granting access. So the paper has advantages like it is most secure because it assumes that there's no entity inherently trustworthy, and it can be adapted to different cloud and computing environments. The next is building a zero trust architecture using Kubernetes. It focused on security of the Versa layer, and The advantages and disadvantages of zero trust architecture. Why zero trust? So, when coming about the current security implementing mechanisms in the software in the IT industry, before there was a traditional security model which followed an approach called trust but verify. So it trusted the uh, internal networks, but it had a trust boundary for external mm, networks, so which had to verify. But zero trust model says trust no one and verify everyone, even in the internal and outer network. So it has a micro segmentation type of trust boundary. And coming to the traditional security model, it is considered to be a secure fortress, and all traffic is inspected and filtered at the perimeter of the network. So whether inside the network, users and devices are trusted by default, but in zero trust it's not the case. Attackers have become more sophisticated, so and are able to bypass the perimeter of security controls. Additionally, this rising of cloud computing security models have made it difficult to maintain this traditional security model, and moving towards the zero trust model, because it allows continuous verification of the services, whereas in traditional it only verifies once. So the hackers can then uh, gradually bypass the perimeter and move it to one service from one to another. So the attackers can move laterally across the networks if they gain any access to one segment. That's the drawback of this traditional security model. The implementing software is SPIFFE and SPIRE. SPIFFE is a secure production identity framework for everyone and is a CNC of project. It defines a framework for identifying and communicating services application, and Spire is a implementation of a SPIFFE framework. Coming to SPIFFE and its concepts. SPIFFE has 5 parts. The 5 parts are SPIFFE ID, SPIFFE verifiable identity document, that is SVID, SPIFFE trust bundle, SPIFFE federation, and workload API. Now talking about the five parts of SPIFFE. The SPIFFE ID is how a software services names is represented. SPIFFE ID, whereas SPIFFE ID is a URI with a SPIFFE schema in start with the authority component that identifies the trust domain as the URL, and the path component as the entity or the workload within the trust domain. So this trust domain in a Kubernetes sense can be a namespace or a service account, and an entity can be the workload like a pod. And SPIFFE trust domain is a namespace or representing a security boundary, or it can be an administrative domain with one or more signing attributes. SPIFFE verifiable document, SVID, is a document which contains this SPIFFE ID, and it is signed by an authority of the trust domain, and it is defined for both X509 certificates and JWT. So this SVD is a cryptographically verifiable document that's used to prove a service's identity to a peer. Now, other component is SPIFFE Trust Bundle. It is a format for representing the collection of public keys given by a SPIFFE issuing authority. So, with the help of a SPIFFE bundle, you can basically validate this SVID. So, SVID, it's like a public key of a it's a public key of a certificate authority that validates this SVID. And workload API is a simple node local API that services use to obtain their identities. Services are workloads, and it provides X509 and JWT SVIDs to the workload when it is authenticated or when it is identified. It is used to it doesn't need any authentication before, so it doesn't have any secrets stored. Next is the Federation API. Federation is a simple mechanism by which SPIFFE trust bundles can be shared across trust domains. So this SPIFFE bundle needs to be shared across SPIFFE trust domains. Normally, an organization or can have multiple trust bundles, that is a bare metal, example a bare metal, or and less trusted cloud domain. So you need to have your bundles coming passed on to the other trust domain, like the less secure cloud domain, which is not trusted inherently. So Federation API allows you to pass these trust bundles to other foreign trust domains, and it's a one way. So in a nutshell, SPIFFE is a cryptographically verifiable secret zero. It solves the secret zero problem, that is when you have a secret that stores some list of secrets, and that main secret should be stored securely. But when that main secret is compromised, all of your secrets can be accessed. So securing the main secret is the hard part, right? So the secret zero problem can be easily solved with SPIFFE, and it is frequently rotated. So the secrets are for timed in for timed. So it is actually renewed for this amount of time period, so that it is not exploited by the attackers if they get any secrets. And it is federable, and which is means it could be passed across trust domains, and it is namespaced and has a uniform identity. So SPIFFE goals are pretty much sharing of SPIFFE SVIDs across trust domains for secure communication across services. Now coming to the SPIRE. SPIRE is implementation of a SPIFFE framework. So it has an architecture of SPIRE, two components of SPIRE server and SPIRE agent. SPIRE server is the main component which serves the SPIRE agents, and SPIRE agent is installed on every node on which your workloads has to be served. So As we saw in the last slides, a federation allows you to pass trust bundles among different trust domains. In this case, this is one trust domain, it's SPIFFE server and SPIFFE agent. So this basically is a Spire implementation of SPIFFE, and this is, you can consider it as one more company or a cloud, or this is as a bare metal exchanging trust bundles for this agent talk to this. So Spire agent has Spire, yeah. Spire agent has a workload API which it serves. So the workload API is basically a node local API to a machine that serves the workloads or services. So workload API issues the SVIDs, that is software verifiable documents, to the workloads, which can be then used by the workloads to tell that, hey, I have an identity, you have an identity, come let's talk to each other, or which can then do its own work. And how would you get this SVID is discussed now. So Spire server, as you saw on this slide, is the one that creates this SVID by signing that SVID and giving it to the Spire agent that is installed on every nodes. Also, Spire agent has a cache, so it doesn't access it from the Spire server every time, and basically when it is being rotated, the Spire server sends the new updated SVID to the Spire agent. If it's not, if it's updated, the cache will get it and check if it's been updated and then replace it. And coming to this architecture of how agent and workload gets their identity verified with the Spire server, it has a plugin type of architecture illustrated with this diagram. So the Spire server and Spire agent have node attester plugins and workload attester plugins. The node attester plugins has a server side plugin connected to Spire server and agent side plugin on the Spire agent side, and work attestator plugin is installed on Spire agent for this workload to be uh, identified and given an SVID. Let's see the working of how this Spire agent on a node is attested initially. So when a Spire agent is come up for the first time, it should be attested. So let's say you have a AWS account and it has a Spire agent in it. So that Spire agent will have a Spire server through which it can be verified. So this node agent first talks to the AWS and asks for its identifying information by using AWS key. It then sends this information to the Spire server. The Spire server sees this information and internally communicates and asks this AWS about this agent's information. If the both information matches, then the Spire server gives the SVID to this Spire agent. That means this node with this agent has been verified. And coming to the workload attestation part, how a workload has been identified and given an SVID. That's the workloads are basically running in any machines, right? So it can be in a Linux environment, Unix, or a Docker or a Kubernetes environment. So when a workload wants to talk to another workload, it then calls this SPIRE workload API. And when it calls for the first time, it doesn't have any SVID. And the SPIRE agent then sees that it doesn't have any SVID. So let me check in my own node machine. Since the workload is running in its own agent machine, both the Spire agent and workload are on the same machine. The Spire agent, with the help of Unix machines, uh, resources like process ID, this workload is internally a process which requests the workload API. This Spire agent identifies this process ID, and then with the help of a plugin of Unix workload attestator, the agent then uh, gets information such as um, it gets the information such as the Linux process ID and the metadata and all those user process information, and then it then keeps it in the P tracker. The P tracker then issues SVID to the workload, which then the workload can then use this SVID for its identification later. So that's how node attesting and workload attesting works, and how internally how each workloads or node agents gets their SVIDs or identity. The benefits of using microservices, the benefits of using Spire is can be to secure microservices which can use X59 or JWT certificates. It can be used to eliminate the API keys. So normally when you connect to a database, you require logins, credentials, APIs to access the database. With Spire, you can remove this API part and authenticate securely with databases. It also bridges the gap between the service meshes. If you are familiar with Kubernetes, service meshes are a way in which Kubernetes services talk to each other, and securing this is much important in Kubernetes environment. It also allows for cross service authentication for different services. It also bridges the gap between different Kubernetes platforms. So this was a rule that allowed SPIFFE service workload called this dataproc1 and dataproc2 to get access to a database with no secrets, with just a SPIFFE ID which was issued by the SPIFFE server to the SPIFFE workloads. So that was it, and that's the performance of SPIFFE Spire. It enables defense in depth without the need to use credentials. It reduces operational complexity. It is interoperable across different environments, multiple stacks. It is compliant and audible. Reality, it can be mutually authenticated using TLS. Conclusion of the seminar is SPIFFE provides you a single unified management solution for workloads in different environments and networks. So this makes a zero trust network easier and be implemented in the current software running industry. So this basically helps you identify any types of software and communicate with others with help of a uniform identity management. Zero trust can be then integrated with other technologies like multi-factor authentication, microsegmentation, and system information and event management for comprehensive zero trust solution. These are the references which I have used it in my seminar, and the credits for the PPT also goes to Evan Gilman, who is the author and founder of this PPT project.